Morning. Thank you so much for coming today technical session. This is the main ASCE last 20 meeting. Today technical session is GI session. Targeting mining beyond and the ASCE last 20 technical question. So today GI session, our GI president Shunmi going to moderate the session. We have two speakers here today. So please enjoy the presentation today.
All right, our topic today will be navigating the depth, tackling the challenges of geotechnical barge drilling on the Brazos River, a case study. We have our two speakers here, Mr. Isidoro Arjona, sorry, hope I speak in that right, is the Senior Vice President and Principal in charge for the North Texas region of Raba Kistner Consultant. Mr. Arjona is a licensed professional engineer in the state of Texas and Minnesota, and is registered as an inspecting engineer by the NRMCA. Mr. Arjona's geotechnical project expertise encompasses challenging subsurface conditions from the expensive clays in Texas to the supersaturated lacustrine clays of Mexico City to the karst conditions in Mexico. Mr. Arjona's professional expertise also involves construction material engineering and testing and environmental consulting. This is our second speaker, Mr. Segu Ifham, is the senior principal engineer responsible for Raba Kistner's geotechnical engineering department in Dallas, Texas. Mr. Ifham is a licensed professional engineer in the state of Texas and Oklahoma, and brings a 22-year track record of expertise in highway and transportation projects across the United States and Canada. Over the past 15 years, he has delivered numerous successful textile projects, including the geotechnical design recommendations for over 200 bridges and 100,000 linear feet of retaining walls, MSC 7-mile drill shaft, and CIP walls. Mr. Ifham has a deep understanding and proficiency with FHWA and textile design requirements. Thank you for speaking with us today, and here you go.
Okay, well, again, the topic of our discussion today is case study. This was a barge drilling project in the Brazos River. And the overview is, first, we'll talk about this geotechnical exploration, what the project consisted of, some of the challenges and solutions in our planning for that project, an unexpected challenge. There will always be unexpected situations, and what our lessons learned were. So basically, as I said, this was a geotechnical exploration project in the Brazos River in Granbury, Texas. This is a Texas project, and it basically consisted of the widening of US 377. These are 9 miles of US 377 from 4 to 6 lanes. And part of that included the widening of the bridge over the Brazos River. The team that participated in the project, Half Associates was the prime consultant. Raba Kistner was part of the team on geotechnical work scope. There were actually 2 geotechnical consultants, but we took the task of doing the drilling on the lake. And basically, we had to drill borings to 120 feet deep below the mud line in the Brazos River to develop the deep foundation design for the bridge widening. This provides a schematic of what the project entails close to Granbury at the Brazos River or Granbury Lake. And basically, the original plan was to drill 5 borings, 3 on the north side of the bridge and 2 on the south side. The scope had to be modified because of reasons that Ifham will explain, but this was the original plan. And here we have a view of the setup of the barge drilling. This was taken with a drone that we use. Basically, you can see the track mounted drill rig on top of the barge conducting the borings right there in the river. And here we have some photographs basically illustrating the conditions inside the barge. Is difficult. Doing a geotechnical project is always challenging, but doing it in a very confined space in the middle of water always creates more challenges. So you can see some of the setup and how we were set up to conduct this drilling. Again, other photographs illustrating the drilling crew, how we would set up the samples, and basically the boats that we would have to transport people to and from the barge as we were drilling. And I will ask Ifham to talk about some of the barge drilling challenges and solutions, how we plan for them.
Hi, good morning. Can you guys hear me at the back? You're fine? Okay. All right, so I'm going to walk you through some of the challenges we have in the project and also how we plan to mitigate those challenges. There are a number of challenges we'll go through one by one. The first one is the project implementation itself is a challenge because we don't do barge drilling on a routine basis. It's pretty rare that we have a project with barge drilling. So the data points, the experience, and the resources are very limited. So we have to come up with a meticulous plan how we are going to execute this project. There are several stakeholders involved in the project. We need to keep them updated and communicated of the progress. And then we also knew, since there are much limited experience and resources, we are going to have some unexpected challenges which we didn't know what, but we should be able to adapt and agile to manage the project. There are many drillers who are qualified and experienced with TexDOT, but when it's come to barge drilling, the drillers and the drilling companies are very limited. So we have to search for the drilling companies, not only throughout Texas, but also in Louisiana, to find the right driller who has the qualification, experience, and also willing to work on this project, because these projects are very high risk, and then not all the drillers want to work on these type of challenges. So we have found few drillers, we checked their experiences, talked to their referrals, evaluated them, and finally shortlisted 2 drillers and interviewed them and selected a driller out of Austin. The driller has a significant amount of experience doing barge drilling, mainly in Austin area, especially in Lake Austin and Lake Lady Bird. And there are several agencies that we have to seek permits from, including Brazos River Authority, Texas Parks and Wildlife, Texas General Land Office, U.S. Army Corps, the city, the county, and the project owner is TexDOT. So we have to go through all the hoops and make sure that we meet their requirements before we begin the drilling. We all know drilling is a pretty unsafe operation. There are several hazards involved in it, but since we do drilling every day, we know how to mitigate and how to handle that. But here we are in a situation where we are drilling from a barge in a lake. So that gives us very minimal or even no reaction time if something goes wrong. So we have to be extra cautious, and we have to kind of prepare ourselves to deal with any unexpected or any safety hazard. We went through a job safety analysis. We developed a site-specific health and safety plan, and the drillers and whoever is on the barge should be aware of the situation and should be able to make decision pretty quickly in order to be safe. We also have to come up with an operation plan, especially when it's come to barge. How do you lower your barge into water? It depends on the water level. If the water level is too low, then you need a crane to basically take the barge and put it in water. Fortunately, the water level is good enough for us to be able to use a boat ramp to launch the barge into the water. And then as you saw in the previous image, we had borings on both south side as well as north side of the bridge. And there are 2 options. We first initiated our drilling from the south side, and to go to the north side, if the water level is too low, then you can actually tow your barge and drill rig under the bridge to go to the other side. But if the water level is too high, then there is not enough headroom. You have to come back and basically unload the drill rig, unassemble the barge, basically carry all of them to the other side of the river, then, assemble the barge again, then load the drill rig. It's a pretty big operation. It's going to take about a week and a half just to do that operation. And we didn't have enough data. We didn't know how much headroom we had. So we basically prepared for all scenarios. We didn't know which one we are going to implement during the project, but our plan was to basically cover every possibility. We also had a tight deadline. I think we started the drilling around late May or early June. And Brazos River already want us to complete everything by July 4th because that is the busiest weekend in the lake, and they don't want any disruption to the boat traffic. So we wanted to maximize daytime. We wanted to drill 12 hours a day. So we were planning to rotate personnel, drillers and loggers. So we maximize the production per day. That requires us to use a personal boat so we can carry back and forth the personnel, use the restroom and whatnot. Surveying is also a challenge. When we do borings on the land, we leave a stake, and the surveys can go later and shoot these borings, but we can't do that on a lake. So for each and every boring, the surveyor says to come and shoot the borings while we do the drilling. So that's needed to be coordinated. So when we actually did the borings, the water level is such that there was enough headroom between the bridge deck and water that we can tow the barge underneath, but not with the drill rig on it. So it's enough for the barge, but not for the barge plus the drill rig. So we unloaded the drill rig at the boat ramp and then just tow the barge only through the bridge. And you can see there's not much gap between the beams and these rods. And these were the two boat ramps that we used to launch the boats and the barge. The one on the south side is owned by Brazos River Authority, and the north one is owned by the city of Granbury. So we had to coordinate with them to make sure we don't disrupt their operations. These are public parks, so we have access as we needed. Here is a picture on the north side of the park where the barge is towed to the boat ramp while the drill rig is taken to the ramp using a truck. And here it is, the drill rig is being loaded to the barge. You can see that it's maneuvered using a remote control. So it's pretty neat device. And here it is loaded and ready to go to the other side of the bridge. The next big challenge is underground utilities. We knew there were 3 lines going parallel to the bridge under the water, a fiber optic cable, water line, and a gas line. And you know how challenging it is. Even on land, damaging a utility line is pretty hazardous. It can have significant consequential damage. Now imagine hitting a gas line underwater, and I don't even know if that is possible to fix that. Most likely these were installed using a directional boring. So if you hit something, if you damage something, it's almost impossible to fix. And the consequential damages will be so high, probably your insurance won't be able to cover that. So we had to be very careful about it. The only data we received from TxDOT is quality level C SU data, which means these utility lines were approximately mapped, and they were not physically verified, which is really not good enough for drilling. It's not really a dependable data. So to make sure we are safe, we wanted to stay away from these map lines. There's also another factor is that when you locate your borings, you use a GPS device, and which has its own error. And on a land, you can actually use physical features to verify and cross-check you are at the right location. You can't do that on water. So there is uncertainty with the utility line, and also uncertainty with your own location. So just to avoid any errors, we wanted to keep a minimum distance of 60 feet away from these map pipelines. The reason for 60 feet is to account for error in the utility map and your GPS, as well as a 10 feet mandatory offset distance from the fiber optical line. So that is how that 60 feet calculated to be. So our operations will be 60 feet away from the pipeline. And once we take the barge to that location, we need to position them, anchor them. And there are 2 ways how you anchor your barge. The easiest method is using spuds. Those are basically steel rods, at the four corners of the barge, and you prop them under gravity. And with the gravitational force, they will basically penetrate into the mud on the river bed. And that's good enough to position or anchor your barge. And then once the drilling is done, then you can pull these rods up. But the limitation with that method is these rods are only 20 feet long. That means your water level should be less than 20 feet, maybe 17, 18 feet to be able to use this method. But most of our boring locations are actually in deep water and we cannot use spud. So we have to go for the other method, which is using anchors. Now, anchors are also similar concept, but instead of vertical rods, you have anchors. Those are 200 feet long, and you just pull them in four directions and ground it. Like imagine a pyramid. Your barge is going to be at the apex of the pyramid, and these anchors are tensioned along the edges of the pyramid to the ground. Now we want to keep our operation 60 feet away from the pipeline, which means our anchors are going to be 6 feet away from the pipeline. Now we have a bridge and there is a pipeline, and then we are 60 feet, our anchor is 60 feet away from the pipeline, and your boat is 200 feet away from the anchor. So if you calculate the total distance between the bridge and the barge, now we are talking about more than 250 feet, maybe 300 feet. So it really doesn't make much sense for you to drill a boring 300 feet away from the bridge. So we have consulted TxDOT, we told them our options, and then we come to a conclusion that we are not going to do borings using anchors. We are just going to relocate the borings such that we are able to locate them and anchor them using spuds. So that changed our scope. This is just a picture of the water line going into the Lake Granbury. You can see these outside, but you really don't know where it is going or how it is going underwater. So here is the map of, all right, so here are the five, basically we want to locate the borings close to the bridge, right? Five borings right here. But we also have these utility lines running there. So we moved our borings 60 feet from the utility just to keep a safe distance right here, like 60 feet. And if you can use the spud method, we can drill the boring right there. But if you have to use the anchor, your anchor is going to be right here, and then you have to go 200 feet to locate your boring, and then the next anchor will go this direction, there and there. So it's like a cross, and this will be a boring location, and this distance between from the bridge to this one is about 250 to 300 feet. And same right here, we cannot do a cross there because there is marina, so we have to come in this direction and use like an X-shaped anchors. So the possible locations for anchors are this location, this one, here, here, and here. All of these locations are really far away from the bridge. So we decided to change the scope and rearrange the boring locations. So we ended up in actually drilling only 3 borings, right? They are close in the shallow water, about 20 feet deep, just because of the logistical reasons. And here's a picture with the spuds like raised up. You can see that. So the barge is at this point floating and you can tow it. Once you reach your required position, then you can lower the spuds and you position your barge. Now it's fixed. We also developed a contingency plan just in case of an emergency. We also plan to leave. Now these borings are pretty deep, 120 feet deep below the mud line, and we have 20 feet of water. So we are talking about 140 feet boring, and we have to grout it. It would take about 5 days to complete a boring. And during these 5 days, we cannot really bring the barge back to the shore. It has to stay at the location. So overnight there will be traffic. So we left some, lightings and everything on just to make sure it's very visible and no one is, running into it. So the drilling finally went well. Actually, we didn't have any weekend breaks because of an issue we had. We had to expedite the schedule. We continued to drilling throughout the project. The drilling went well, and we were under the constant supervision of inspectors and all different agencies. It went well, but there was a hiccup, and that is what Isidoro is going to talk about.
So as Ifham mentioned, we thought we had thought of all the possible challenges that we could find, but there was one we didn't think of. Basically, we hired a specialized drilling subcontractor who has done this type of work extensively in the Austin area. He ended up renting barges from a third party, and these people work together a lot in the Austin area, in Lake Austin, Lady Bird Lake. Lake Austin, Lady Bird Lake are infested with zebra mussels, and it's so bad that it is state law that whenever you move a boat or any watercraft from one lake, you need to decontaminate it. But I guess the situation is so bad in Austin that they don't even do that. And because these people work primarily in those areas, they forgot to do that decontamination before moving the barges to the Brazos River. As I don't know if you're familiar with that, but zebra mussels are an invasive species that have a very, very negative impact on the environment. Texas law prohibits transport or introduction into public waters. And basically, the barge supplier failed to decontaminate them before transporting them to the Brazos River. So we were very fortunate that in the boat ramp that belongs to the Brazos River Authority, there were inspectors looking at everything. And just before it was launched into the water, they observed that there were some zebra mussels on the hull of the barge. As I mentioned, state law prohibits the introduction of zebra mussels, so everything came to a halt. We immediately mobilized on site to observe the situation, and there was an emergency response that involved the Brazos River Authority, the city of Granbury, Hood County, and a number of stakeholders, and communication and rapid response was critical. We can see some of the zebra mussels that were stuck on the hull of the barge. These are very difficult. Sometimes pipe systems and so on, once they get in there, they can cause all kinds of problems. As I mentioned, state law prohibits the transport of them. The barge provider retained a company to deliver them, and they were unloading the barge and they wanted to leave for another site. And wait a minute, the authorities immediately said, you're not going anywhere. There's going to be a decontamination and we're going to go to a process here. So the truck driver was halted from driving away, and the officials identified a possible site for decontamination far away from the lake. And this was a construction site basically at the Granbury airport. There is construction going on, and there was a large area that was covered with gravel for construction. That was a site that Hood County and the city of Granbury designated for that decontamination. And basically, we have the barge that was mobilized away from the lake and into this construction site where the risk of zebra mussel spreading was very, very low. So here we have them. They are starting to unload the barge into tarps so that any of those mussels that fall down can be contained and taken away. Again, other photographs of how, under the supervision of Texas Parks and Wildlife biologists and people from Hood County and city of Granbury, they started the process of decontaminating all the equipment that was suspect of containing zebra mussels. Now, it was good that this was discovered before the barge went into the water, but there was still a question. Did any zebra mussels fall onto the ground or the boat ramp that can eventually make it to the lake? So Texas Parks and Wildlife inspectors do a thorough inspection of the boat ramp, and they didn't find anything. But out of an abundance of caution, Hood County decided to bring in a flat wheeler roller compactor to make sure to go through the entire boat ramp. And if there was any zebra mussel that may have remained, that would be crushed and it would not make it into the water. So here we have a Hood County flat wheel compactor that was used to go through the entire boat ramp just to make sure, out of an excess of caution, that nothing would go and cause damage into the Brazos River, Granbury Lake. Here we have another photograph showing just how pervasive, once the zebra mussels come into the bottom of the barge, They just get stuck there, and it's very, very difficult to get them out of there. So the next challenge was, what is the decontamination protocol? Basically, Texas Parks and Wildlife had the solutions on how to do it, but they wanted the responsible party, which was the barge supplier, who was the people in the first place that should have decontaminated and not transported it, to develop a decontamination plan. And basically, the plan involves decontaminating with water at very high temperature, 140 degrees Fahrenheit, and then a 2-week drying period. That period of heat will allow the zebra mussels to die, and then a reinspection would happen by Texas Parks and Wildlife. And the decontamination plan was created by the barge supplier right there on the spot. It was reviewed by Texas Parks and Wildlife, approved, and they decided to go ahead. And basically what it was getting the tarps, getting the barge in the middle, and then that would be a place where it would be basically applied at high pressure water on the very high temperature, collect all of that in that tarp, and then let them sit under the Texas sun for an extended period of time to make sure that all of the mussels died. Here we have some example of how they set up those tarps. Again, this area is very far away from the lake. So even if some of the mussels fell into this ground, the risk was pretty minimal. And this other photograph shows just how pervasive, when those zebra mussels, they can get into very tight spaces, and they just get stuck in there and cause all kinds of problems. And that's why there's such a concern for Texas Parks and Wildlife. Here we have other photographs illustrating the setup of how all of that was implemented. Again, you can see those zebra mussels stuck close to the all of the items of the barge. Just they were everywhere. So eventually, the decontamination process was held. Texas Parks and Wildlife conducted a reinspection, and once they considered it to be safe to get the barge in the water, we were authorized, we went back there, and we proceeded with the project in the way that Ifham described. What are the lessons learned and the conclusions? Verify, 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 triple verify. You should not assume that because you have sub-consultants who are qualified, that they will think of everything possible. We were hiring, as Ifham mentioned, we interviewed people from throughout Texas and Louisiana to find a driller who had the experience to do this. We did not realize that he didn't own the barge. He was renting that barge, and that the people who own it, because they work in an area where zebra mussels are so prevalent, no longer thinks of the state laws when they need to transport a watercraft to another area. Some of the lessons learned: verification of utility locations. Utilities are always a challenge on land. In the water is even more challenging because of the uncertainty on where exactly they are. Verify the qualifications of all your subcontractors and go to every possible tier. Make sure that even at third tier or beyond, that there's coordination, there's understanding of the regulations involved, and that everybody will perform as a plan requires. And you think that professionals would know what the regulations are to their specific tasks. Don't assume that. Have to verify every time. Pre-planning is key. Without proper preparation, we would not have been able to execute this project in time. And as Ifham mentioned, there was a big concern from all authorities to get this project completed before the 4th of July. That's the day when there's the most people attending the lake, people on jet skis, people on boats, people doing all kinds of things, which increases the level of risk. Expect the unexpected. Things will happen in a high risk situation like this one. Rapid response is critical. Be cooperative and adaptive. the rapid response that we were able to achieve here would not have been possible if it hadn't for for all of the people involved from the different authorities to work together and find a solution. If red tape had come into play, I don't know that this would have been able to get resolved in the time that it did. Maintain open channels of communication and trust with all project stakeholders is critical. A lot of the problems in engineering projects are not the engineering, is a communication and the trust. And consider contingencies whenever you schedule a project. This is critical. Contingencies will always come, and how you respond to them is key. And with that, I open it for questions. There's another view of the setup. Again, we took a drone to take a view of the operations when they were going. You can see how little room there is inside the barge for all of the equipment that's needed, all of the tools, sample handling, and so on. So it's always a challenging and interesting setup. And with that, we open for questions. Yes.
Have any issues with the actual drilling? Where did you find?
No, we didn't have any issue. It's limestone. It's Glen Rose limestone. The drilling went really well. Yes.
Who was that contractor? Come on.
Well, we'd rather say it offline. We don't want to put anybody on a bad spot here, but yeah. Yes.
Who absorbed the cost for the decontamination?
That was the responsible party. That was the barge owners, because they were the ones who violated state law. They were the ones who transported it in violation of state law, and they were the ones who had to cover all of that cost.
You have some delay costs from the other contractors?
You know, the entire team, TechDOT and our clients they worked with us. Even though there were delays to the project, we were able to recover schedule and get the project done before the 4th of July. So we didn't assess delay charges to them. We just tried to work together to come to a solution. The solution being make sure the decontamination happened, and we were authorized to proceed with the project. But we didn't.
When we received the drilling, we didn't take any breaks. We didn't have any weekends. We just simply rotated the personnel and then kept going. So we were able to catch up the delay.
Mhm.
What's the top of the limestone?
Pretty shallow, maybe 20 feet from the bottom.
Yeah, limestone is fairly shallow in that area, Granbury. Yes.
I've managed many textile projects and fortunately haven't had to do drilling of water like this. It's kind of preparing me in that case I have to. So do you get your feed from the drillers ahead before you know if you won the project or not? Because usually textile only gives you a couple of weeks to put your feed together and you notified. So I just kind of logistically, I'm just curious how the handle this sort of projects.
This because this is non-standard work, as you say, very seldom do you see this. We had to go through a negotiation process that took months, many
It's not
months.
the usual process.
No, it wasn't the usual process. We really had to take some reference projects in the Corpus Christi area where barge drilling was done, take some of that cost and go through the approval process because it was really non-standard drilling. So the unit costs and the ODEs that TechDOT has as standards statewide didn't really apply here. We had to get special rates approved for this work. Yes.
I think like samples underwater.
Sorry, say that again.
How did they collect samples underwater?
Mostly it's rock quarrying. So from 20 feet onward, it's limestone. So we were doing bedrock quarrying. About that, I have to check. I think we just took SPDs. I don't think we had any initial materials.
SPT being standard penetration test. So basically the split spoon sampler is what we took. And the rock cores with the rock core sample.
Thank you for Join our main technical session.
Sure.